You've probably heard of sine and cosine when dealing with trigonometry before. In this video, we're going to be talking about how to graph these functions. First, let's go over some background. On the unit circle is you go from 0 degrees or 0 radians to 360 degrees or 2 pi radians. Sine and cosine will both get bigger and then smaller repeatedly. This is because they are periodic. This term basically means that the function's graph will repeat at set intervals. Let's look at the sine curve. It may not be so clear here because it's only a small portion of the graph, but this curve will go on forever. This part is the part that repeats. This is one period of the sine graph. One period goes from 0 to 2 pi. The period can change, however, depending on transformations, which we'll get to a little later. Alright, now like other types of functions, the trig functions can be transformed. For sine, you can use this equation in the dark blue to figure these transformations out. In this transformations equation, A is the amplitude, B helps you find the period, C is the horizontal shift, which we call the phase shift, and D is the midline. The amplitude, or A, is how far the highest and lowest points, or the relative maximums and minimums are from the midline. The midline D is in between these highest and lowest points. In the parent function, the midline will be at y equals 0. It's a horizontal line, but it's not actually there on the graph. It's more like a line which we use to reference our other points. You can use C to figure out where on the midline the first point is. Finally, B is very important. Like I said before, the period can change, and you need to figure out how big one period of your specific function is. For this, you can use the equation 2 pi over b. Then, to make life easier, you can use the increment, which is the period over 4, to figure out where your points at the maxes, mins, and midline are. The increment works because all of these main points are spaced apart equally. Let's try graphing this equation. So here we have y equals 3 sine of 2x plus pi minus 1. Okay, so first notice that the x is not isolated here. It's being multiplied, or it's connected to the 2. Now think back to our transformations equation. The x was isolated, and we had our b factored out. So we need to get what's in the parentheses to match our transformations equation. To do that, we're going to factor out the 2. When you factor the 2 out, you get 2 times the quantity of x plus pi over 2. Now, if you have a little trouble figuring out what you get after you factor it out, because it can be a little confusing with all the pi's and stuff, you can set up an equation like this. So we have 2x plus pi. Then you can say what times 2 will give us pi. This works because when you multiply the 2 by the pi root 2, you're supposed to get pi. So that's essentially what you're representing by this equation. So when you solve this, you'll get the question mark equals pi over 2, which is our c value. Okay, so now to graph, I like to use an acronym called YAPPI. I know it's a little weird, but just roll with it, it works, and it's very helpful. So it goes YAPPI. Okay, so let me just rewrite this equation really quickly. Okay, now y here is our midline, because remember, our midline is like a horizontal line, so it has the equation y equals a number. And we can use d to figure out the midline. For this, d will be -1. So our midline will have the equation of y equals -1. A stands for the amplitude. And remember, the amplitude comes from a in the transformations function. So here it will be 3. So our amplitude is 3. So the first p is phase shift, which comes from our c value. Our c value here is pi over 2. So now think back to our transformations equation. We had x minus c. Now this is very similar to other equations like quadratic and square root, cube root, all of those. So like those equations, we're going to go essentially the opposite way the sign is telling us to. So we have a plus sign here, so we're going to go left pi over 2. Okay, our second P is for the period because you need to figure out how big one period of your graph is. So again, to find the period, we're going to use 2 pi over b. And in this case, b is 2. So if we plug that in, we'll get 2 pi over 2, which is just pi. So our period is pi. Finally, our increment is 1/4 of the period, so that's just pi over 4. Okay, so my graph here does not have a scale, so the first thing that I'm going to do is scale the graph. So I usually go by 1/2 of the increment just so it gets spaced apart a little better, not squished. So in this case, on the x-axis, I'll go by pi over 8. On the y-axis, just use the amplitude and the midline. So in this case, I'll go by 1s. So I'm just going to go ahead and scale this off screen. Now for the actual graphing. So first thing that we have to do is graph our midline. So our midline is at y equals -1. So I'm going to go ahead and do a dashed line at y equals -1. Okay, so now think back to the original sine graph. Our first point is on the midline. So our midline is at y equals -1, we have that. But it also has the phase shift applied. So our first point is going to be at -pi/2, -1. Okay, our second point is a maximum. And it's going to be pi over 4, which I got from the increment, away from our first point. So I'm going to go right pi over 4, and then I'm going to use our amplitude, and I'm going to go up 3, so up by the amplitude, because it's a maximum. So our next point will be at -pi over 4, 2. Okay, our third point is going to be back on the midline, and pi over 4 away from the previous one. So it's going to be at 0, -1. Okay, our fourth point is a minimum. So we're going to be going down by the amplitude from the midline. And again, it's going to be pi over 4 away from our previous point. So it's going to be at pi over 4, -4. And our final point is back on the midline. And it's pi over 4 away from the previous one. So it's going to be at pi over 2, -1. Okay, so now let's go ahead and connect all of these. And there you have it. That's one period of this function. Now, if you want a better graph in general throughout this whole video, I recommend go on Desmos and just put it in, or use the graphing calculator. It will help. Okay, anyways, I did want to go over how a negative sine function would look like. So say we had -3 sine of 2x plus pi minus 1. So the whole YAPPI acronym, that would not change at all. What would change is the graph's shape. So what essentially happens is this maximum will become a minimum. So it will be down here. And then this minimum will become a maximum up here. Okay, so that is our function. Let's move on to cosine. Cosine is basically just sine shifted left pi over 2. So we can still use the acronym YAPPI, and it still has the same transformations equation, just with cosine instead of sine, obviously. And the first point on cosine is not at the origin, it's at 0, +1. And that's, again, because it's sine shifted left pi over 2. Let's try a practice problem. I'm not going to go very slowly with this because once you can graph sine, you can graph cosine the other way around. Okay, so here we have y equals -1/2 cosine of x minus pi. Now the first thing you want to look at is our x isolated? Is it being multiplied by anything? Is it connected to anything? And here, it's not, so we're all good. Okay, now you probably noticed the negative sign. Now think about how that affected our sine curve. It made all of the maximums into minimums and vice versa. So the same thing is going to happen to cosine. So say this is our normal positive cosine curve. With the negative, this maximum will become a minimum, and the minimums will become maximums, and you will get something like that. Okay, now let's bring back a YAPPI. So again, that's YAPPI. Okay, now for our midline, there isn't a visible t value in our function, so that means that it's just plus 0. So our midline is at 0. So it has an equation of y equals 0. Our amplitude is 1/2, so a equals 1/2. Okay, our phase shift, which we're going to use c for, is going to be right pi. C is pi, and we have a negative sign, so we're going right. Our period is 2 pi over b, and over here b is just going to be 1. So our period is 2 pi over 1, which is just 2 pi. And then our increment is going to be 2 pi over 4, so pi over 2. I'm going to go ahead and scale this graph off screen the same way I did the last one. Okay, so first our midline is at y equals 0, so let's go ahead and graph that. Okay, now our first point, remember, for cosine, when it's negative, is a minimum. So we're going to use our amplitude and our phase shift here. So we're going to go right pi, then we're going to go down by 1/2. So our first point is going to be at pi negative 1/2. Okay, our second point is on the midline. So we're going to use our increment and we're going to go right pi over 2 from our first point and then back at the midline. So it's going to be at 3 pi over 2, 0. Our next point is a maximum. So again, we're going to go right pi over 2 and then we're going to go up by the amplitude, so up 1/2, and it's going to be at 2 pi 1/2. Then our next point is going to be back down at the midline, pi over 2 away. Then our last point is going to be a minimum again, pi over 2 away. And now we can go ahead and connect these points. Okay, so now if you think that this graph doesn't really look like the one that we drew in our little mini graph up top, just remember that the graph will repeat, right? It'll go left and right again. So when we extend it, it'll go up like that. So this section here, that matches, right? So that's basically it. Thanks for watching. Hope this helped. Bye-bye.